Good afternoon, everybody. So, in this lecture today, we're going to talk about average value and area between curves. They're both pretty simple. It's just a matter of just navigating your way through each problem and thinking about, what is actually happening. So, first, I'd like to define average value. So, the average value on F, average value of F on, now this is notation for a closed interval, meaning you're starting at A and you're ending at B, okay? So the average value of F on the closed interval A to B is equal to 1 over B minus A times the integral from A to B of f of x dx. So a really easy example of this. All right, let's just find the average value of f of x equals the square root of x from x equals 0 to x equals 9. All right. So if you just use the formula provided above, it's going to be the average value is going to equal 1 over 9 minus 0 times the integral from 0 to 9 of x to the 1/2 dx, because square root of x is x to the 1/2. So that's going to equal 1/9 times 2/3 x to the 3/2. All right. And then what I have to do is evaluate this between 0 and 9. So to simplify things up a little bit, I'm going to get 2 over 27 times times 9 to the 3/2 power minus 2 over 27 times 0 to the 2/3 power. And if you want to, you can go ahead and get your calculator out. If you don't want to do that, 2 over 27 times the square root of 9 cubed. All right, well, we know the square root of 9 is going to be 3, and 3 cubed is 27. So it's 2 over 27 times 27, where the 27s reduce. So the average value is 2. Okay? Let's look at another example here using average value. Okay, I got a couple of them actually. So the population of the United States, so of the U.S., is predicted to be P of t equals 310 e to the 0.0073 t. Okay? Million people. Where t is the number of years since 2010. Predict the average population between the years 2020 and 2030, which is the time frame that we are living right now. So as soon as you see the words or the word average, you should be thinking, okay, I'm going to use that average value formula. So the average value is going to equal 1 over. Now, the thing we have to be aware of is that t is defined as the number of years since 2010, okay? So if we're concerned with the years 2020 to 2030, then the number of years since 2010 is going to be 20 minus 10, because 2030 minus 2010 is 20, and then 2020 minus 2010 is 10. Times the integral from 10 to 20 of 310 e to the 0.0073 t dt, okay? So I'm going to take this 310, and I'm going to pull it out front. So that's going to give me 310 over 10 times the integral of 10 from 10 to 20 of e to the 0.0073t dt. All right, now that's going to give me 31 times, now this is e to the 0.0073t, so we know when we integrate that, it's going to be 1 over 0.0073 e to the 0.0073 t, and we have to evaluate this between 10 and 20, okay? So what I did is I just went ahead and I just used my calculator for this. So I got approximately 4,247 e to the 0.146 minus 4,247 e to the 0.073, okay? And when you go ahead and crunch those numbers, it's approximately 346, which means the average population of the United States during the years of 2020 and 2030 will be about 346 million people. Okay? I think the population of the United States is about 328 million right now. Let's see, population of USA. 327.2 million. Okay, so, and that's as of 2018. This year was a census year, so hopefully you did your census. Doing that's very important because that dictates where a lot of funding and everything goes, especially for the neighborhoods that you live in. So make sure you do your census. Anyways, so between 2020 and 2030, it's looking to be about 346 million people. I would like to be able to remember this problem 10 years from now, to see just what the population really was, to see how accurate this model really is. All right? So now we're going to talk about the area between curves. Okay, and there is a method to do this, okay? Now, in your book, they kind of do it the opposite way, and I don't know why. It doesn't make sense to me. So here's what we're going to do. The first thing you always want to do is you want to graph, okay? Now, to help us, you can use your calculator, or you can go to this website, www.desmos.com. You can also download the app on your Android or Apple phone. The app is free, so that's great. So once you graph, the second thing you're going to want to do, all right, is you're going to label. Okay, you're going to label each function that you graphed. And then the third is you're going to apply this. It's a little bit of a formula, but once you see it in action, it completely makes sense. So you're going to integrate from A to B the upper curve minus the lower curve, okay? And that's going to be with respect to x, all right? So graph, label, and then use common sense to label the upper and the lower curve, all right? So let me show you what I'm talking about here, okay? Let's find the area between y equals 3x squared plus 4 and y equals 2x minus 1 from x equals -1 to x equals 2, okay? So first thing I'm going to do, let's go back to this. All right, I'm going to go to Desmos. So I'm going to get a new blank graph here. And I'm going to go ahead and graph these, okay? So I get y equals 3x squared plus 4. There's my first graph. And then the second one is going to be y equals 2x minus 1. Okay? So let me go ahead and let's clean this up a little bit here. So I'm going to go to properties. I'm going to change my x-axis to, what are we going from? -1 to 2? So let's go from -3 to 4. That'll be my x-axis. Not 14, 4. All right, and then my y-axis, where am I going from again? -1? Actually, yeah, that'll work. -1 to 2. So my y-axis, let's make it -5 to 12. Nope, 12 is not going to work. 15? 15 is not going to work. You'll see why in a second. Let's go 20. 20 will work. Okay. All right, now I'm going to take a picture of this. And let's go ahead and let's just put it here. All right, so here's what we're talking about here. All right. The first graph that I graphed was a red line, and that's going to be y equals 3x squared plus 4. The second line I graphed was the blue line, and that's going to be y equals 2x minus 1. So step 1 was graph, step 2 is label. Now they also want me to find the area in between these two curves from x equals -1 to x equals -2. So right here is x equals -1, so I'm going to draw a solid line. And then the 2. So notice the area that we're concerned with is all right here. That's the area we want to find. Okay? So as you can see here, this is the red curve is going to be my upper, and then the blue curve will be my lower, okay? So when I go ahead and I apply my formula, I'm going to integrate from -1 to 1, and I'm going to write the upper curve first. Oh, -1 to 2, I'm sorry. So I write my upper curve, 3x squared minus 4. Oh, sorry, 3x squared plus 4. Let me write that better. So it's going to be 3x squared plus 4 minus, and then your lower curve, 2x minus 1, all in parentheses. Make sure you put the upper and the lower always in parentheses, okay? Because you have that negative right there, and you don't want to forget that you have to distribute that, okay? So the first thing I'm going to do before I do any calculus work, I'm going to do algebra work. I'm going to go ahead and distribute 3x squared plus 4 minus 2x plus 1 dx. Okay? And I'm going to go ahead and group like terms. So the integral from -1 to 2 of 3x squared minus 2x plus 5 dx. So now that all my simplification work is done, I can see right here it's going to be an easy integral for me to figure out. So it's going to be x cubed minus x squared plus 5x evaluated between -1 and 2. So that's going to give me, let me put a bracket here. Wherever I see an x, I'm going to put parentheses and make my substitution. So here's my upper limit. Minus, same thing again, wherever I see the x, I put parentheses first. Make my substitutions. And then there's my lower limit. And if you just type it in exactly how it looks into your calculator, you're going to get 21. So the area between the upper and lower curves, 21 square units, whatever the units happen to be, okay? Let's do another one here. Okay, let's do another one. Let's find the area between the curves y equals 12 minus 3x squared and y equals 4x plus 5. Okay? And this is going to be from x equals 0 to x equals 3. All right? So, once again, I'm going to go back to Desmos. I'm going to go ahead and graph these. All right? So, let's see what we get here. So, the first curve is going to be 12. So, y equals 12 minus 3x squared. All right? And the second curve is going to be y equals 4x plus 5. And we want to go from x equals 0 to x equals 3. So give me 1 second here, because I'm going to have to zoom out here. Yeah. Let's do this. We'll go from, how about -1 all the way up to, let's say, 5. All right. And I think that's good right there. We'll leave it just like that. All right, and you'll see why. All right. Okay, so here's the picture. Now, when I go ahead and label this, remember the green line is going to be y equals 12 minus 3x squared. And the purple line is going to be y equals 4x plus 5. And we're going to evaluate from x equals 0 to x equals 3. So right here is 0, and right here is 3. Okay? And hopefully you can see something here. Notice that when I start shading stuff in, notice in this first region, the upper function is 12 minus 3x squared. Okay, this is the upper function for the first region. However, in the second region, notice that the upper function now changes. They flop each other. They flip-flop. So it's going to be y equals 4x plus 5. So because of that, all right, there we go. I had to erase that. Because of that, what we need to do is we need to find the area of the first region and add it to the area of the second region, okay? In other words, area total is going to equal area 1 plus area 2. So we actually have to do 2 little mini problems, okay? So now the question becomes, well, what's that right there? Okay? Well, if you graph first, you could clearly see that that x value is 1. So it looks like for the very first region, we're going to go from x equals 0 to x equals 1. And then for the second region, we start off at 1, and then we're going to end all the way over here on the right-hand side at x equals 3. Okay? But what I'm going to do is I'm going to show you how to actually calculate that. Okay? Because sometimes you may not have a graphing device. So it's like, well, how would I know that then? Okay? So step 1, graph. Step 2, label. That's what we did. Step 3, now we're going to go ahead and we're going to solve our problem. We're going to set up our problem, okay? So to find the intersection, okay, of the two regions involved. All right, so to find this point right here, the black point that I'm kind of over exaggerating how large it is, all right? So to find that point, here's what we know. We know that at that point right there, y equals 12 minus 3x squared has to equal y equals 4x plus 5 because they cross right there. So set each equation equal to each other. All right, so that's what I'm going to do. So I'm going to take 12 minus 3x squared and set it equal to 4x plus 5. So now I see the x squared term right here. So I'm thinking quadratic formula or factor or anything like that. More importantly, let's set this equal to 0. Because I can't factor, I can't quadratic formula, I can't complete the square until the equation is set equal to 0 first. So let me just rewrite the equation here. All right, and what I'm going to do is I'm going to add 3x squared to both sides. That gives me 12 equals 3x squared plus 4x plus 5. And then I'm going to subtract 12 from everything to give me 0 equals 3x squared plus 4x minus 7. Okay? So I went ahead earlier and I factored this to give me 3x plus 7 and x minus 1. Now I will set each factor equal to 0. For the first, that's going to be x equals negative 7 over 3. Okay? Well, when we go back up here to the graph, I don't care about x equals negative 7 over 3 because I'm evaluating between x equals 0 and x equals 3. So that negative 7 over 3 is not between those two numbers. So I don't care about this. What I care about is I add 1 to both sides. X equals 1. So I know they cross at x equals 1. And these two lines, they also cross at x equals negative 7 over 3. But since that is not within our closed region or a closed interval, I don't care. All right? So here's what we have. We're going to have two integrals for two regions. The first region is going to be the integral from 0 to 1 of the upper, all right, which is going to be 12 minus 3x squared, minus the lower, 4x plus 5, all right, and this whole thing, dx, plus, now here is my second region. That region is going to start at 1 and end at 3 of the upper, well, in this case, in region 2, the upper is 4x plus 5, and the lower is 12 minus 3x squared dx, all right? So this is A1 plus this is A2. And when I add them together, that will give me the total area, okay? So now it's just a matter of grouping like terms and then integrating. So for the first integral, I get negative 3x squared minus 4x plus 7 dx, plus for the second integral, I get 3x squared plus 4x minus 7 dx. All right. Now when I integrate, okay, for the first one, I'm going to get negative x cubed minus 2x squared plus 7x, and I have to evaluate that between 0 and 1, plus for the second one, I get x cubed plus 2x squared minus 7x evaluated between 1 and 3. All right? So when you go ahead and you make all your substitutions, you're going to get negative 1 minus 2 plus 7, okay? Minus 0, because that goes to 0, that 0, and that's 0 when you substitute in 0. Okay, so that one's pretty simple. And then for the second one, you're going to get, so let me put this in brackets here. So this is still our upper. Now my lower, this is going to be 27 plus 18 minus 21 minus 1 plus 2 minus 7. And when you type all this into your calculator the exact way it looks, you're going to get 32. Okay? You're going to get 32. All right, so we got one more question here. All right, one more question. And this question deals with areas bounded by curves. Okay? And what we mean by bounded by curves is that the area itself is going to be trapped inside two curves. So far, if you look like right here, we specified from x equals 0 to x equals 3. We told you where to go. Even in the previous problem, x equals -1 all the way up to x equals 2. We told you where to go. All right? What if I don't tell you? Okay? So, find the area between y equals 3x squared minus 12 and y equals 12 minus 3x squared. Okay? So, let's pretend, for example, we didn't have a graphing calculator. All right? Here's what we know. We know that if these two curves are bounded, which means they cross, all right, that means they have to intersect somewhere. Where do they intersect? The intersection will occur between, let's say, I don't like the word between. How about this? The intersection will occur when 3x squared minus 12 is equal to 12 minus 3x squared. All right? So what I'm going to do is I'm going to solve this first, and then we'll graph it just to make sure we're correct. So from here, I see the x squared terms, so I'm going to get them together. So let's add 3x squared to both sides. So that's going to give me 6x squared minus 12 equals 12. Okay? Now I'm going to subtract 12 from both sides to give me 6x squared minus 24 equals 0. Now I got this equal to 0 because I have x squared terms. And as soon as I see x squared, I'm going to set it equal to 0 so I can factor or quadratic formula. So here I'm going to factor out x, or this 6 to give me 6 times x squared minus 4. Now I know if I wanted to, I can divide both sides by 6, and that's just going to give me x squared minus 4. That is a difference of squares, which means I can factor it down into x plus 2, x minus 2. And last but not least, I will set each one of these factors equal to 0. And I will find that the intersection of these two functions will occur at x equals -2 and x equals +2. Well, let's go to Desmos. Let's just see if we're correct. So I'm just going to go to new graph here. All right. And the first one is going to be y equals 3x squared minus 12. Okay. And the second one is going to be y equals 12 minus 3x squared. All right. So let me clean this up a little bit here. All right. So let's see here. Where do my y values go? Okay, they go all the way up to, what is that? All right, that's 12. That's what I thought. So let's change the properties. Let's go from, and we're going to make this look real pretty. So we're going to go from -3 to 3. And then we're going to go from -15 to +15. All right. Now, the x values we found, -2 and 2. Look what we have right here. negative 2, and 2. So let's go ahead, let's snip this. Let's put this in our notes. All right. And as you can see here, the area that is bounded is going to be right here. All right. It's all this area that's bounded between negative 2 and positive 2. So the upper y equals 3x squared minus 12. The lower y equals 12 minus 3x squared. So this is going to be the integral from negative 2 to 2 of 12 minus 3x squared minus 3x squared minus 12 dx. Let's simplify first. Okay, let's simplify everything first. So you're going to get 24 minus 6x squared dx. And when you integrate that, you're going to get 24x minus 2x cubed evaluated between negative 2 and 2, which gives me, for my upper limit, 48 minus 16, and then for my lower limit, negative 48 plus 16. And if you were to type that into your calculator, you're going to get 64. So the area between those two curves is 64 square units. All right? And that's going to be it for this lecture. So we have one more section in this chapter. We're going to skip 5.5. And we're going to go right into 5.6, which is integration by U substitution. All right? So I will see you in the next lecture. Bye.